Okay, you have the Excel files. You can download it from your Blackboard. I think I posted it here. If you go to the module 4, the sample for chi-square-test. I'm sure you could do for the visualization if you run Excel program. Click on the insert menu and then choose chart. Before you choose chart, you need to highlight all the data. Then you can get that information. So from here, you can get, I believe, this. What we will do is, here, those two types of attack, and then that attack occur continually. At some points, it stops. So we count the frequency of those code injection and secure shell demand attack frequencies. So 75 times of code injection continually occurring, and so far we have 2,425 stops, and similarly secure shell demand attack as well. So this is the actual frequencies. So total we have 5,000 cases observed. This is the only given. So given this, we need to check if there is some relationships, so that we can say, oh, it occurs and eventually stop, or it keep occurring, or is there any relationships with the code injection or and secure shell attack. So that type of things needs to be determined by statistical form. So one of the tests is chi-square test. Chi-square test has, usually set null hypothesis, which means two variables are independent. That is the first hypothesis. Then second hypothesis, they are not. Okay, only two hypotheses. They are related or not related. But first hypothesis is they are not related, so-called independence. In this statistics, from the Excel program, we can get chi-square test value and also p-values. If p-values is 5%, then we can say significantly they are independent. Lower than 5%, then highly significantly they are independent. Lower than 1%, then less likely they are independent. Very low, very, very low, then you can say almost independent, which means they are not dependent. How can you get this number? Before we get that number, based upon observed frequencies, we need to generate expected frequencies. These expected frequencies can be generated based upon the probabilities. For example, out of 5,000 cases, this slot occurs 205, 250, 2,500 and 159. Okay, according to this, 195 and do this 2,500. So what we could have here is that by clicking this cell, press equal sign, equal button, and click. What we want to do is we want to first, this cell multiplied by that cell divided by that entire. That is the probabilities. So click this, then it appears D5. I'm going to formulate this cell, and then I'm going to copy the same formula to right and to lower. When I copy the formula, I do not want to break these numbers, which means when I copy to right, I do not relatively the reference to right, which means I do not move this column to right. Although I copy the formula from here to right, I want to lock the column. To do that, if you press F4 multiple times, look at this, then it keeps changing the dollar sign, position of a dollar sign. If dollar sign appears, the letter, then it means column is locked. It appears number in front of a number, then it means the row is locked. What I want to do for this, I want to lock the column only, which means I need to lock the D, right? And then I want to do multiply this, or not, multiply this by that. Again, when I copy this cell to lower cell, I do not want to transit this location to the lower location. If I move this to lower location, there's nothing, right? I want to keep the row position, which means the number position. So by pressing F4, I want to keep dollar sign in front of that number 7. And then finally, divide it by this 50, 100. This 50, 100, I do not want to move to right. I do not want it to move to lower. I want to lock column and row together. So by pressing F4, all together, $D and $7, and press enter. And by click this, press your mouse lower right corner, then there is a small square, and your mouse will be a tiny cross. At that point, drag and drop to lower cell, and all together now highlighted and to right, and all copied. Apparently, as you can see here, they are equally between this, but based upon that probabilities, it occurs and that occurs. They are the same number, but you can see here there's a 0.5 together, then it is a 195, right? So decimal point is important in this case. And same thing here. All the global number never changes. So this is expected frequency, this is observed, this is real fact. Now we need to calculate chi-square test, and then p-values. Click on this, press equal sign, and then move your mouse over the function, insert function, and then click all. Then you can see all the functions, but I wanted to choose chi-square dot test. There's a chi-square dot test, right? And click on OK. There are two text boxes, actual range and expected range. Actual range is the range of those 4 data. So you can highlight those 4 data. Therefore, the range address is from B5 to C6. Apparently that is those 4 ones. And then again here, for actual, same thing. So from B12 to C13. So we have the 2 ranges for each, actual range and expected range. And then finally click OK button. Then we have this number, which is, what is that? 0.001011, very, very small number. What is the interpretation for this? Outcome, p-value outcome. That is even smaller than 1%, which means less likely independent. This hypothesis is less like. What do we mean by that? So those two cases are not independent, meaning they are highly dependent, right? This and this are very, very highly dependent. What is the implication to our data mining? Those two columns can be associated. We may be able to combine any patterns, any predicates based upon those two attributes together. We can conjunct them. And it means much more significant. All right, this is it. Thank you.